do the Chapter 6 test. Graph the area enclosed by f of x and g of x in the first quadrant. So I'm going to graph it. In the first quadrant. And so let's see. If I put in 0, 0 times pi divided by 4 is 0. Sine of 0 is 0 times 3, 0. If I put in 4, I get the sine of pi is 0 again. If I put in 2, sine of pi over 2, 2/4 is pi over is 1/2, so pi over 2 is 1 times 3 is 3. So this must be a sine curve that's doing something like this. Okay, now let's do this. This looks like it's a parabola. If I put in 0, I get 0 squared, which is 0 times 3, which is 0. If I put in 2, 2 divided by 2 is 1 times 3 is 3. And if I put in 1, 1/2 squared is 1/4 times 3 is 3/4. So that would be somewhere in here. So this parabola goes like this. And it's a parabola centered, and it's just 3/4 of normal height. So this is kind of what we have, is this area here that I'm supposed to write. And it just says, now set up the integral to find the enclosed area. Okay, so the area, we'll do a slice this way, so it's dx, and we'd be integrating from 0 to 2, and it'll be the higher curve, which is 3 sine pi x divided by 4, minus the lower curve, which is 3 times x over 2 squared. And that's it. All there is to it. You could work that one out, but didn't ask you to do it. Number 2, I forgot to state the interval, so I put that on the board in class. For those taking the test, it says graph the area under the curve. So we got to graph this between 0 and 4. So if I put 4 in there, I get 1 over the square root of 5. Nope, if I put 0 in there, I get 1 over the square root of 1, which is 1. What am I talking? I put 0 in there, I get 1 over the square root of 1, which is 1. If I put 1 in there, I get 1 over the square root of 2, which is 0.7. And if I put in 2, I get 1 over the square root of 5, which is 0.4. And this continues going down. If I put 4 in there, I get 4 squared is 16 plus 1 is 1 over the square root of 17, which is even smaller, so it's just curving down. If you actually graph it on the calculator, it'll do something like that, but we only need from 0 to 4. And then it says determine the integral that would find the volume. So that'd be pi integral pi r squared, if we're going to slice it this way, rotating about the x-axis. So pi r squared, and r is y, and y is this, 1 over the square root of 1 plus x squared, squared dx, evaluated from 0 to 4. Well, if you square that, you get pi integral from 0 to 4 of 1 over 1 plus x squared dx, which is pi tangent inverse of x, evaluated from 0 to 4, which is pi tangent inverse of 4, and tangent inverse of 0 is 0, so that's gone. Just to check that, tangent inverse of 0 is 0, no matter what my mode is in, but it should be in radians. And then, so if I wanted the decimal approximation, I'd have pi tangent inverse of 4, which is 4.165 approximately cubic units. Number 3. The population of buffalo around a watering hole has a radial density of this. So if we were to look at that, that's going to graph and get smaller as you get further away from the watering hole. That's what this does. You could type it in and graph it. And it says set up an integral. Now, what you're doing, this is the population per square kilometer. So we need to find out how many square kilometers are at a certain radius. So we make a ring around the watering hole, and the ring will have a width of dr, and if you unwrap it, it's a rectangle that's this long, which is 2 pi r around. So if you take dr times 2 pi r, we get the area of this ring, and then we take it times the population density at that radius, and we get the volume, the number of buffalo on that ring. So we're going to take the integral from 0 to 2 kilometers out of 2 pi r times the density dr. So dr times the r, 2 pi r is the area, times the density function, give you the number of buffalo at that distance out. And you have to do all of them from 0 to 2. Now to solve this integral, so I've set up the integral. Now to evaluate it, I'm going to do u substitution. So I'm going to let u equal the inside there, 1 plus 0.2 r squared. So du would equal 0.4 r. If I take 2 times 0.2, get 0.4 dr. So solving for dr, it's du, excuse me, over 0.4 r. And that r will cancel the r in our original. So I'll try to keep this where you can see it. So I'm going to take the 5 out. So I'm going to have 10 pi integral, new limits. If I put in 0, 1 plus 0 squared times that is just 1. And if I put in 2, 2 squared is 4, times 0.2 is 0.8. 1 plus 0.8 is 1.8. And this being my u limits. And I have an r, the 5 I've taken out, times the 2 pi. I have u to the minus 2. And I have, in place of dr, du over 0.4 r. The r's will cancel. I can take the 0.4 out, and the integral of u to the minus 2 will be, so 10 divided by 0.4 is 25. And u to the minus 2 will go to u to the minus 1 divided by minus 1, evaluated from 1 to 1.8, which would be 25 pi times, this would be minus 1, puts it in the denominator, 1 over u, minus, and so I'm going to get 1 over 1.8 minus 1 over 1.8 minus a minus, or plus 1 over 1, and that will be minus 1 divided by 1.8 plus 1 is 0.44444 times 25 pi, and we have about 35 buffalo. This is 25 pi times, this works out to be 4/9. So I got 100/9 pi buffalo, or 35, approximately. Number 4, derive the formula for the volume of a cone with a radius r and the height h. So, makes sense to slice it this way. So if I make this direction y, this would be dy. And the area of that, this would be in the x direction. So the radius would be x, so I can write the formula, pi r squared times the thickness dy, evaluated when y goes from 0 to h, or h to 0 to h, depending on where we make y be 0 at, 0 to h. But that's got an x in it. So now, I got the choice of putting y being 0 up here, and then this would be y, or I can put y down here, and this would be h minus y. Now, what I'm going to choose is to put the y here, and this part being h minus y, so that I can do this similar triangles here, and I want to find x, so I could say x to y is the same as h is to r. X to y is the same as r to h. X short to long, that ratio. So I need to replace x, so I can multiply by y on both sides. And I can put this in for the x in this equation, and I would get pi 0 to h of r squared over h squared y squared dy. And the r's and h's are constant, so I got r squared over h squared pi, and y squared integrated would be y to the third over 3, evaluated from 0 to h, And if I put h in here, I get h cubed, so I'm going to get r squared times a pi over h squared, and then an h to the third over 3, and so I get pi over 3, or 1/3 pi r squared, and this h squared reduces this to just an h, r squared h, which is the formula for the code. Number 5. First, we're supposed to graph these. And we're doing it from 0 to 2, so I'll just make that in the first quadrant here. X cubed, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. And then y equals 0, and x equal 2. And this says rotated about x equal minus 2. So that would be rotated about a line over here. So I probably should have graphed it over further, but that's okay. So I got this. This is the y-axis. This is 2. This is 2. So there's my graph. We want 0 to 2 around this line using the disk method. So if this is the axis, x equal minus 2, we'll slice it horizontally. So we're going to get a washer with an inside radius and outside radius. So we're going to do large circle minus the inside circle. So it's going to be pi integral from, see, this is going to be dy. So y is going to go from 0 to 8. And it's going to be large radius, which is going to be, that's x plus 2 squared minus the small radius, which would be this x plus 2, and it's always 2. X is always 2 on this one, so we can say 2 plus 2, because the large radius is always 4, minus the small radius, which is 2 plus that x, squared. So now we need to find out what that x is in terms of y. So looking at this, y equals x to the third. If I take both sides to the 1/3 power, which is the cube root, that cancels, and I get y to the 1/3 goes in there. So I'd have pi integral from 0 to 8. 2 plus 2 squared is 4 squared, 16, minus parenthesis 2 plus the cube root of y squared dy. Now, let's set up the shell method. Now, if I'm doing the shell method on this, I'm going to make a slice parallel to the axis. The axis is over here. If I make a slice parallel to it, it's going to have a thickness that's dx. It's going to make a circle, a shell, like this. That's going to be over to here, the same radius as that we had here, 2 plus x. So writing it down here, we're going to have integral. The dx is going to go from 0 to 2. X is going to go from 0 to 2. It's going to be a ring ring that's going to be a long rectangle. That's rectangular solid, I should say. That's dx thick. The distance around is going to be the radius, which is 2 plus x. 2 pi r, that's the length. The height will be y, and the thickness is dx. Okay? Now, write it down so you can see it. There we go. So 2 pi, radius is 2 plus x. The height of the ring is y dx. And this y is x to the third. So this becomes 2 pi integral from 0 to 2 x plus 2 times x to the third dx. So if I were to work this one out, which part C does, if I did it with this one, I would get 2 pi integral from 0 to 2 of x to the fourth plus 2x to the third dx. And then if I integrate this, I get x to the fifth over 5 plus 2x to the fourth over 4 times 2 pi. Evaluate from 0 to 2. 0 is not going to give me anything, so I'm going to get 2 pi 32 fifths plus 32 fourths. So that would turn out to be, common denominator is 20, so I multiply this by 4, and that's 128. Plus multiply this by 5, that's 15, 150, 160. Let's see. Multiply by 5. 5 times 2 is 10. Carry it. 5 to 15, 16. Yes. So 2 pi times 288 over 20. And the 2 would reduce this to 10. So I'd get 28.8 pi, or 28.8 or 28 4/5 pi. Let's see if I get the same thing from this one. So I have pi integral from 0 to 8 of 16 minus 2, if I have to square this quantity, I would have 2 times 2, which is 4, plus 2 cube roots of y, plus 2 cube roots of y, plus 4 cube roots of y, plus cube root times a cube root is cube root of y squared, or y to the 2/3 power dy. And then if I distribute this minus, then I have pi integral from 0 to 8 of 16 plus a negative 4 is 12 minus 4y to the 1/3 minus y to the 2/3 dy, which would equal pi 12y minus, let's see, 1/3 plus 1 is 4/3, so 3/4 times 4 is just 3y to the 4/3 minus, and 2/3 plus 1 is 5/3, 3/5 y to the 5/3. Evaluated from 0 to 8. 0 is going to give me nothing, so it should be just the 8. So I got pi. 8 times 12 is 96. Cube root of 8 is 2. 2 to the 4th is 16 times 3 is 48. Cube root of 8 is 2. To the 5th is 32. Times 3 is 96. Minus 96/5. So 96 minus 48 is 48. And 5 will go in there. 20, let's see, 19 and 4/5. Is that right? Minus 5 goes in there. Once, 46, 9 and 1/5. 48 minus 20 would be 28, but it's not 20, it's only 1/5, so I got 4/5 more, so that's 28 and 4/5. So I get 28 and 4/5 pi, which is the same answer as I have down there. Okay. And finally, the back page. We have a trough, and its depth is 5 meters, and the width at the top is 5 meters, and it's 5 meters in length, 12 meters in length. So if we're going to do a trough and we're going to pump the water out of this, we would probably want to take a slice this way, because a slice this way will all be lifted the same amount. So this is the direction I'm going to slice it, and that would be a rectangle. And then if I call up and down y, that would be thickness of dy. So the volume of this is going to depend here. So now I have to decide, is y 0 here or y 0 at the bottom? Now, probably most of you put y 0 down here, so this would be y, and this would be 5 minus y, the height we have to lift it. So we're going to go through this. We got to do, we got to figure out the weight of this, which will be the force, because work is force times the distance. The force is going to be weight. And in this case, since we know the density of water, we have to take density. We have to get the weight is mass times acceleration due to gravity, and mass is going to be density times volume. So then we're going to have to take that times acceleration due to gravity, and then we're going to have to take that times the distance we're lifting it to get the work. So we're going to do the volume of this slice, And we're going to take it times the density due to gravity, which is of water, it's 1,000 kilograms per meter cubed, times the acceleration due to gravity, which is 9.8 meters per second squared. And the volume is going to be this width times 12. And this width changes as y goes up. So if I put y here and then put that as x, or actually I'll make this whole thing x, but since the height and the width are the same there, the height and the width would be the same there, and the height and the width would be the same there. So it's the same all the time. So whatever this width is, it's also equal to the height, which is y. So it's going to be 12 times y times dy. There's the volume times all this. So we got the density times the volume times the acceleration to the gravity times the height we have to lift it, which is 5 minus y. And we're going to integrate that. Y is going to go from 0 to 5. So we get, actually we probably should say from 5, we're going to take where it is at the top to the bottom. So 5 minus 2, 0. Okay. So this is 9/8 times 12. Let's get all of this here. 9800 times 12 is, in case you didn't see that, 11760. 11760 integral, so I've taken care of the 12, the 9.8, the 1,000 of 5y minus y squared dy from 5 to 0. Starting from 5 and working our way down to 0. So this is going to integrate to 11760 5y squared over 2 minus y squared cubed over 3 from 5 to 0, which is going to be 11760. Put in 0, we get nothing. Minus, put in the 5, we're going to get 125 over 2 minus 125 over 3. And looks like I should have not changed my limits around because this is going to be more than this. So this is going to be, if I multiply by 3, I'm going to get 3 of these over 6 minus 2 of these over 6. So I'm going to get 125 over 6 for this. It would be minus, so I should have had my limits stay the way I had them to start with, 0 to 5. 0 to 5, 0 to 5, and I'll get this times that, which will be divide by 6 times 125, and I get total amount of work to be 245,000. 2,450,000 joules. And that should be it.